All right, welcome to the Explainer. Today we're going to tackle a real classic JavaScript mystery. You know, it's one of those things that usually starts with a developer knee-deep in someone else's code who just stumbles upon a puzzle.
So this developer, right, they see two different ways of writing a function, and they're thinking, okay, they look almost the same. Why are there two? Is one of them, like, the right way to do it?
I mean, look at them. On the surface, they seem to do the exact same thing. Both of them make a function, right? But, and this is the key, that tiny little difference in syntax, it hides a huge difference in how JavaScript actually sees and runs your code. So yeah, let's dive in and unpack this.
Okay, so to really solve this mystery, we've got to get the lingo down. We can't just call them two ways of doing things. They have official names. And believe me, those names matter because they come with their own set of rules.
So this first one, var function1 equals function, that's what we call a function expression. The easiest way to think about it is that the function itself is just a value. It's no different than a number or a piece of text that you're just, assigning to a variable. And then we have the second style. This one's called a function declaration. It's way more direct. You're not really assigning anything. You're making a formal statement. You're telling the JavaScript engine, hey, pay attention. Here's a function, and its name is function2.
All right, so now we have the names, function expression, function declaration. Now we can unlock the secret behind why they act so differently. And it all boils down to this one kind of magical-sounding concept in JavaScript, hoisting.
And this is where things get, well, a little weird. You know how you're always told that code runs from top to bottom? Well, with one of these function types, it's almost like that rule doesn't apply.
So check this out. With a function declaration, you can actually call the function before it even shows up in your file. And it just works. No errors, nothing. This is super handy, by the way. It lets you put your main, important logic right at the top of your file where it's easy to see and tuck all the helper functions away at the bottom.
But if you try that exact same thing with our function expression, bam, your program crashes and burns. You get a big, fat type error that says function1 is not a function. So, what in the world is going on here? Why does one work and the other one break?
The answer, my friends, is hoisting. Here's the deal. Before your code even runs, the JavaScript engine does this quick pre-scan. It looks for all your declarations and kind of hoists them up to the top of the scope. But here's the kicker. What it hoists is totally different for our two function styles.
For a function declaration, the engine grabs the whole shebang. I'm talking the name, function2, and all the code inside its curly braces. It hoists the entire thing to the top. It's like it's been there, fully ready to go from the very beginning.
But for a function expression? Oh, it's a totally different story. The engine sees var function1, and it says, okay, I'll hoist that variable declaration, and that's it. So the variable function1 exists at the top, but its value is undefined. The actual function part, that doesn't get assigned until the code execution physically hits that line.
And look, this isn't just some nerdy trivia question for a tech interview. This difference has real everyday consequences for how you write your code and, more importantly, how you track down bugs. So let's see how this plays out in the real world.
Yeah, trying to call a function expression before it's actually assigned is a super common bug. It's a classic rookie mistake, but honestly, it can trip up anyone. So understanding hoisting isn't just about knowing some cool party trick, it's about writing code that's more predictable and way less buggy.
This table breaks it down perfectly. A function declaration, it just works, no problem. An expression with var, you get that type error because you're basically telling JavaScript, hey, run undefined. And it's like, what? And then with the newer let or const, it's even stricter. The variable is in what's called the temporal dead zone, or TDZ, so you get a reference error. The code knows the variable will exist, but you can't touch it yet.
Okay, so beyond hoisting, there's another really important reason to care about this. And it has everything to do with what happens when things, inevitably break, and you have to go on a bug hunt.
So here's a pro tip. Even when you're using a function expression, you can still give it a name, like this, var myfunc equals function inner name and close. And doing this can be an absolute lifesaver when you're debugging. It's one of those things that a lot of developers say is seriously underrated.
I mean, this quote from a developer on Stack Overflow just hits the nail on the head. When your code breaks and the error message just says it happened in an anonymous function, that's so unhelpful. But if it says the error is in calculate invoice total, boom, you know exactly where to look.
Now, to be fair, modern JavaScript is pretty smart. A lot of the time, it'll guess the function's name from the variable you assign it to. That's what you see on the left. But If you explicitly name it, like on the right, you get total control. You guarantee the best possible name for your error messages, and it also makes it super easy for a function to call itself, for recursion.
All right, let's wrap this all up. Think of this next slide as your cheat sheet. This is the TLDR on when to use which function syntax.
So here's the bottom line. Use function declarations for your general-purpose helper functions, the ones you want to have available everywhere in your file. Then use function expressions when you need that extra flexibility. Think callbacks or functions that you only want to define if some condition is true. It's all about picking the right tool for the job. So, now that you know the secret, how is it going to change the way you write and debug your code? Because really, understanding this core difference, it takes you to the next level. You're not just someone who writes code that works. You're someone who understands why it works. And that's a real game changer.